Hello there and welcome back to the Science Sleepy Minds. Tonight, you're falling, slowly, silently, down into something you're not supposed to understand. There's no wind, no sound, just the gentle pressure of inevitability tugging at your body like a dream that won't let go. The stars above, still there for now, stretch and smear like wet paint across the cosmic dome. Somewhere behind you, a pale blue planet spins unknowingly on, as if you hadn't just stepped past the line. They call it the event horizon. A lovely name, like something you'd hear in a sci-fi novel, written by someone with a poet's soul and a mild caffeine addiction. But this is no metaphor. This is the edge. Past this boundary, nothing escapes. No light, no messages, no desperate escape plans, and certainly not you. You probably won't survive this. Just a heads up. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Drop your location and your local time down in the comments, especially if you're up past your bedtime again. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You don't fall into a black hole like you'd fall into a canyon. There's no hard jolt, no cliffs. You glide, smoothly. The darkness ahead doesn't just look black, it looks wrong. It curves light itself, like the air above hot pavement. Except this isn't a heat shimmer. This is space-time bending into a well so deep that even the laws of physics look over the edge and decide to stay behind. Around the event horizon, space is no longer a passive backdrop. It's alive. It pulls. And as you cross the threshold, your first thought isn't panic, it's awe. The transition is strangely anticlimactic. You expect alarms or some Star Trek style, "We're crossing the boundary" moment. Instead, it's quiet. From your perspective, nothing wild happens as you pass the horizon. You just keep falling. But if someone were watching you from outside, they'd see a different story. They'd see you slow down. They'd see your descent stretch toward forever, frozen, forever teetering on the edge, never quite vanishing. You don't get to wave goodbye. The light from your face takes longer and longer to reach anyone looking in. Eventually it redshifts into darkness. From their perspective, you become a ghost. A fading smear of light hanging in time. But from your view inside, you're still moving. Very much so. Remember how they taught you in school that light always travels at the same speed? That it's the cosmic speed limit? That rule still holds, but the road beneath it is warping. You're falling down a funnel where time itself stretches and curves, and it only gets weirder from here. Historically, the idea of a black hole came long before we had any real evidence for one. In 1784, an English natural philosopher named John Michell suggested that a star could be so massive and its gravity so intense that not even light could escape. This wasn't based on relativity. It predated Einstein by over a century. He was using Newtonian physics and still managed to dream up a dark star. Pretty impressive for a guy working with quill pens and candlelight. But modern black holes? They were born out of Einstein's general theory of relativity in 1915, then solidified by Carl Schwarzschild, who found the first solution describing such a thing just a few months later. His work predicted the event horizon, though at the time even he didn't quite grasp how bizarre the implications were. And oh, the implications. You look up, at least you think it's up. Directions are meaningless now. The stars above look distorted, smeared, more intense. This is gravitational lensing in action. Light from distant galaxies is bending around the black hole, curving through space like marbles rolling along a warped trampoline. A quirk of physics that lets you see things behind the black hole, even though they should be hidden. Light takes the scenic route now. Historians still argue whether the first proper black hole ever discovered, Cygnus X1, in the 1960s was truly the first, or just the first we understood well enough to call by name. What's certain is that once it was confirmed, the floodgates opened. The universe, it turned out, was littered with these things, stellar mass ones, supermassive ones, ones at the hearts of galaxies, and maybe, just maybe, microscopic ones left over from the Big Bang itself. You'll meet those later, but right now you're focused on this one. It's probably about 10 times the mass of our Sun. Modest, by black hole standards, the kind formed when a massive star burns out and collapses under its own weight. It didn't go quietly. The core crunched inward, the outer layers exploded out in a supernova, and what remained was this perfect prison of light and time and gravity. Somewhere deep inside, the laws of physics are taking off their shoes and pretending this doesn't concern them, but not yet. For now, you're still outside the real trouble zone. And you know what's weird? You feel normal. No crushing force, no dramatic rumbles, just the feeling of falling, but without wind, without ground, without any sense of scale. The horizon is behind you now. There's no going back. You imagine screaming, but your voice wouldn't carry. Not because there's no air, of course there's no air, but because even if it could travel, it would never escape. The sound would stretch, slow, and fade into meaninglessness, like shouting into a dream. Some theories suggest that if you had a long enough spaceship or a magic rope, you could anchor one end outside the horizon and slowly reel yourself in. But the moment you cross that line, the math says otherwise. You can try pulling back all you want. The black hole has already won. Every direction you move is now inward. Even up just takes you deeper. Strangely, you remember that time you lost your balance on an escalator and tipped forward in slow motion. Your coffee rose into the air like a magician's trick, time stretching across a second that felt like 10. That's what this is. An infinite escalator, except the bottom is a singularity and the coffee is, well, irrelevant now. And yes, there are other, much weirder interpretations of what this experience is like. In some theories, black holes don't destroy you. They copy you, or teleport you, or erase only your surface while preserving some strange version of your information on the event horizon itself. Don't worry, we'll get to that. Plenty of mind melters ahead, but for now, you fall. The stars above blur, the light behind dims, and the pull becomes something more than just physical. It's spiritual, existential, and surprisingly, not scary. You're not screaming, and you're watching. You drift downward, or what feels like downward, though direction has officially thrown in the towel. Gravity isn't just pulling on you anymore, it's sculpting you. You're being stretched, and not in the relaxing post-yoga way. Your head is closer to the black hole's center than your feet, so it's falling just a little faster. A tiny difference, at first. But give it a few kilometers, and that difference starts to matter. This is the beginning of something astrophysicists call tidal forces, but you'll soon come to know it by its far more dramatic nickname, Spaghettification. Yes, that's the real term. Scientists can be cheeky too, but right now it's subtle. You feel a light pressure, like something is gently coaxing your atoms to elongate. Your limbs want to stretch. Your organs want to sigh apart. It's not painful, yet. It's almost meditative, like being pulled through warm syrup. Very, very determined syrup. Outside the event horizon, gravity curves the path of objects in space. But inside it, gravity curves you. Not just your body, but your experience of time, of reality, of what you even means. At this depth, the laws of physics are doing the awkward shuffle where they don't make eye contact with one another. Historians still argue whether Einstein himself believed black holes were real objects, or just strange theoretical artifacts that emerge from his equations. What we know for sure is that Einstein deeply distrusted singularities. The idea of a point with infinite density and zero volume just didn't sit right with him. Honestly, fair enough. But for you, the math doesn't care. You're living, well, falling, proof that something is happening here. And it's happening fast. Strangely, you don't feel heavier. That's the part no one tells you. Gravity isn't felt as a force pulling you down. It's felt as the absence of a surface pushing you up. On Earth, your weight is just the floor pushing against you. Here, there is no floor, no push, just fall. You're in freefall like astronauts orbiting Earth, except your orbit is spiraling inward and there's no coming back around. Let's rewind the camera for a moment. Imagine you're holding a friend by the ankles, dangling them feet first into the black hole. Classic prank. As you lower them in, the tidal forces pull harder and harder on their feet than their head. Eventually, the difference becomes extreme enough to pull them apart. Yes, vertically, like taffy or noodles. The word spaghettification starts to feel a little less funny now. Here's the twist. The size of the black hole matters. Smaller black holes, like the one you're falling into, create stronger tidal forces near the event horizon. That means spaghettification happens before you even get close to the center. But if you were lucky enough to fall into a supermassive black hole, like Sagittarius A star at the center of our galaxy, the event horizon is so large and the gradient of gravity so gentle that you could pass the horizon without even noticing. In that scenario, you'd fall deeper, farther, perhaps even have time to write a journal entry or two. In this one, well, let's just say the spaghetti timer is ticking. You begin to notice that your body feels long, not uncomfortable, not painful, just unusually tall in every direction. You're a human stretched across space-time, a vertical ghost. If someone could see you now, though no one can, they'd say you look like a Salvador Dali painting had a baby with a yoga instructor. And the weirdness isn't limited to your body. Objects fall differently here. If you dropped a flashlight, it wouldn't fall down the way it used to. It might hover for a second, caught between conflicting flows of curved space. Then it would spiral inward, bending in slow loops, as though space itself were reluctant to give it up. Light moves here, but not the way you remember. It's like watching a film that's melting in the projector. You recall one of the strangest quirks you read about black holes. Inside the event horizon, time and space switch roles. Time becomes directional, like moving toward the center. You can't stop yourself any more than you can stop Tuesday from becoming Wednesday. Space becomes weirdly optional. You can go left or right. Maybe, if space hasn't already given up trying. This is the part where most equations start to scream. There's something quietly terrifying about the idea that you can't stop falling. Not because you're being pulled, but because there's nowhere else to go. It's not motion in the normal sense. You're being carried like a leaf down a river. But the river is time, and time has a destination. A fringe idea, discussed mostly in speculative corners of physics forums, suggests that the stretching isn't just physical, it's informational. That the very pattern of you, the structure of your thoughts, is being unspooled into something like a cosmic barcode, decoded not by eyes, but by the geometry of the universe itself. Creepy, absolutely. Proven, not even close. But this is black hole science, where the lines between physics, philosophy and bedtime stories start to blur. A curious thought drifts by, uninvited but sticky. If you're being stretched so much, what's happening to your brain? Is your perception slowing down? Do your thoughts get longer, more syrupy? Would a single idea take years to process? Or would your awareness simply snap like a violin string under too much tension? No one knows. No one can know, because no one comes back from where you're going. There are theories, yes, and mathematical models and very clever debates over late-night whiteboards, but data? Not so much. You think about the Apollo astronauts and how they trained for the unexpected, about the Voyager probe still floating out past Pluto, untouched and mostly forgotten. You wonder, could one of those lonely little machines ever survive a trip like this? Probably not. They weren't built for falling into monsters, but something about that makes you feel less alone. People have been looking toward these cosmic abysses for centuries. Philosophers feared them, poets romanticized them, and now here you are, living their nightmare and their dream in equal measure. Every meter deeper the stretch increases, and still no pain. Only this dreamy, elongated sense of self. You're no longer sure how long you've been falling. Seconds, years. Time is melting like a candle left too close to a fire. All that remains is descent. Gentle, irresistible. You pass something, maybe a boundary, maybe just a feeling, and the sensation changes. The gravity isn't just vertical anymore, it's inward, pulling at you from every side. You feel like you're folding inward, spiraling like water down a drain. But there's no water and no drain, just darkness, and a growing sense that you are not where you were, or even who you were anymore. Time, as you knew it, is already gone, not just warped or slowed, but twisted into something alien. To someone watching from far outside the black hole, you're practically frozen in place. That moment when you first crossed the event horizon, it still hangs there, suspended in the light that never quite escapes. A still life portrait of your last second as a normal being, preserved in warped light like cosmic amber. But inside you're still moving, still falling, still thinking, though that's becoming a little harder to define. It's strange. You still feel time passing in a personal, internal sort of way. Your thoughts come in sequence, one after another, but everything outside, it's sped up, ridiculously so. The further you go, the more the clock outside accelerates. Galaxies swirl faster, stars blaze and burn out in the blink of a heartbeat. You're not just falling into space, you're falling into the future. This is time dilation in its most extreme form. Einstein predicted it with his general theory of relativity. The deeper you sink into a gravity well, the slower your time moves relative to someone in weaker gravity. It's why astronauts age a tiny bit slower than people on Earth. But near a black hole, this effect becomes surreal. If someone were watching you from a safe orbit, say, a few thousand kilometers above the event horizon, they'd see your descent grind to a halt. You'd appear to hover forever just above the edge, growing redder and dimmer as your light shifts into longer and longer wavelengths. Eventually you'd fade to infrared, then radio, then nothing. A soft flicker, a disappearance that takes eternity. From their perspective, you never enter. But from your perspective, their time is accelerating. Blink, and they've lived a century. Blink again, and their descendants are waving at your shadow from a brand new civilization, assuming their telescopes are good enough. Blink once more, and stars begin to die. Galaxies fade. The background radiation cools. The cosmos empties out. You're falling forward in space but sideways through time. The idea that you could watch the end of the universe just by falling into a black hole is more than poetic. It's plausible. Physicists have suggested that theoretically, an observer could glimpse the far future as they fell inward. The compression of external time becomes so extreme that billions of years could pass before you hit the center. You're an unwilling time traveler with a one-way ticket. And here's the kicker. Time dilation doesn't just affect your perception of others, it affects theirs of you. From their point of view, you're immortal, forever balanced on the edge of the abyss, never quite tipping in. Like Schrödinger's astronaut, both alive and doomed depending on who's watching and when. This makes black holes messy from a physics standpoint. Is the version of you that fell in still real? or just a hologram of light plastered on the horizon for others to see? Historians still argue whether this illusion counts as a true death, or if the real you dies much later, deeper, and less photogenically. Let's back up slightly for a mainstream example. In 1971, 2 clocks were flown on airplanes around the world in opposite directions, while identical ones stayed on the ground. When they reunited, the airborne clocks were off by a few billionths of a second. Tiny, but measurable. That's time dilation in action. It's been verified again and again, even affecting the satellites in your GPS. Without accounting for relativity, your phone would think you're somewhere in the next town over. Now crank that up by several orders of magnitude, and you get what you're experiencing now. You're not just a few billionths off, you're millions of years apart from the world outside. The people who knew you are long gone. Their species might be extinct. Their sun could be dead. But here, in your cozy little gravity coffin, it's still now. The deeper you go, the more later the universe becomes. A fun side note. One fringe theory suggests that black holes might be time machines of a sort. Not the cool, back to the dinosaur kind, sorry. But some researchers propose that certain black holes, particularly the rotating kind, could allow for closed time-like curves. That means, under the right conditions, time might loop. Not travel backward per se, but circle around. Think of it like space-time tying itself into a knot and pretending nothing happened. Is that what's happening to you? Hard to say. You certainly don't feel looped. Just stretched, slowed, and increasingly unrecognizable. You reach a point where looking outward shows you a universe in fast forward. Galaxies spin into each other, merge, die, and dissolve. Light dims. The cosmos cools toward entropy. The last photons flicker like dying fireflies. Some theories suggest this takes trillions of years. For you, it's more like watching the world exhale its final breath. Over lunch. Then there's the fringe stuff. Some speculative physicists propose that inside a black hole time might stop entirely. That the singularity represents not just the end of space, but the halting of time itself. Not slowed, not looped, just zero. Zilch. No before, no after, no tick, no tock. You enter as a creature of time and exit as something else. This, of course, opens the philosophical floodgates. If your experience ends but outside time continues, did you really stop existing? Or did you just hit pause on a cosmic scale? Does consciousness require time to function? Or could it flicker once eternally at the moment before singularity? Questions with no answers. Not yet. You try to speak, though your voice won't travel. Just a whisper in your mind. Maybe it's a prayer. Maybe it's a science fact you remembered from high school. Time slows near mass, you mumble to yourself. Closer you get, the more distorted it becomes. Congratulations, you're living the distortion now. You look inward again. There's still further to fall. The horizon is behind you. The singularity, whatever that means, is ahead. Space is bending more tightly around you. Your stretched self, your dilated seconds, your elongated thoughts, they're all merging into something new. Time isn't just slower here, it's fading. And so are you. You try to remember something, anything from the world above. A name, a sound, the scent of rain on warm pavement. But everything feels distant now, like trying to recall the details of a dream hours after waking. You're falling still, that part's certain, but the rest of you is being gently pried loose, like pieces of a jigsaw puzzle dissolving in reverse order. Outside, the universe races ahead. Stars are being born, living full lives, and collapsing into their own black holes in the time it takes you to blink. Civilizations rise and fall. Maybe one of them finds your story etched in some ancient data file, catalogued under Unsolved Cosmic Mysteries, episode 438. They won't know what became of you. They won't even know you existed, only that a sensor once recorded a flicker of matter crossing an invisible boundary and never coming back. That's your last footprint, a ghost signature in a gravity well. And now even the signals are fading. Your last attempts to transmit anything have stretched into oblivion. The photons you sent out, frantically at first, then more slowly, like someone tossing messages in bottles into a boiling sea, are now too redshifted to be detected. They've become long, lazy waves of nothing. You could beam the secrets of the universe out at full strength, and it wouldn't matter. No one hears you. This isn't silence, it's something deeper, a quiet that swallows the idea of sound itself. Saying goodbye to the universe isn't like closing a door, it's like watching the entire building vanish while you're still standing inside it. A quirky tidbit from the history of black hole observations. In 2019, when astronomers finally imaged the event horizon of the supermassive black hole in the galaxy M87, they captured something humanity had never truly seen before. A glowing ring of infalling matter, light orbiting near the edge, and a central shadow that confirmed decades of theory. A photo of absence. And yet, it felt like presence. Proof that this thing, this ancient abyss, was real. You think about that image now, wondering if someone might one day photograph the hole you're falling into. Will your black hole get its moment of fame, a ring of fire around a pit of silence, or will it be one of the uncounted billions scattered across the cosmos, anonymous and waiting? Your memories begin to fuzz at the edges, faces you loved become harder to picture. Not because of time exactly, more like your brain knows they're irrelevant now, like a radio slowly losing its station. The signal fades, replaced by static, then silence. You look up, whatever that means now. The universe outside is nearly gone. Not visually, it's still technically visible, though shrunken into a bizarre sphere of light that surrounds you. It's shrinking fast, like someone dimming the lights in reverse. The stars you knew are compressed into a flickering halo directly above. It's like falling into a well and looking up to see the sky as a pinhole. And then the pinhole dims. You've lost contact with space. Now it's time to lose contact with time. That phrase hits different when it's literal. There's a point. No one knows exactly where or how smoothly it happens, where space and time start to break down in earnest. Not just warp, not just stretch, but actually become tangled. The coordinates you use to define your world, up, down, past, future, they've become squishy. Mathematically, this is where classical physics throws in the towel. Equations start giving back answers like undefined, or infinite, or please stop asking. It's a little like typing the wrong thing into a calculator and getting a face emoji in return. The universe shrugs. I don't know, try quantum gravity. Historians still argue whether we'll ever get a true theory of everything, one that marries the vast scales of relativity with the twitchy chaos of quantum mechanics. But if we do, it's probably buried somewhere near this moment you're living. If living is even the word anymore, a part of you wonders if your consciousness is changing. Not in a spiritual sense, but in the way information might behave when falling into a system where even light gives up. Does thought obey gravity? Is awareness a function of time or something that floats above it? You notice something else. You don't really feel like you anymore. Not in the egoic human way. You're still here, experiencing, sensing, but stripped of context. You can't remember your last meal. You can't remember your name. It doesn't feel scary. It feels like returning to a default setting you didn't know existed. You've stopped accelerating, at least from your perspective. That's a fun twist. Once you're inside the event horizon, you fall at the speed of light, but you don't feel it. There's no sense of rush, no blur. just a smooth slide into something deeper. This is what physicists mean when they say there's no force of gravity in general relativity. Gravity isn't a thing pulling on you. It's the shape of space-time, and you're just following the lines. You're not being forced into anything. You're simply taking the only path left to you. You are now the path. And here comes another philosophical curveball. What if you never reach the singularity? Not because it doesn't exist, but because your experience of time stretches infinitely before you get there. Some theories suggest you could fall forever, asymptotically approaching that center without ever making contact. That your experience just keeps going, getting stranger and slower, like the universe pressing pause on a frame it never wants to unfreeze. Or maybe it's already happened. Maybe that last stretch, the one where you felt your memories fading, was the singularity, and you're already on the other side, whatever that means. Is there an other side? No one knows. Seriously, it's not just a mystery, it's the mystery. Quirky side note. In some solutions to Einstein's equations, if you extend them far enough, black holes do have other sides, portals to other universes, or white holes, hypothetical regions where matter is expelled instead of swallowed, like a cosmic digestive system, black hole in, white hole out. Astronomers haven't found one yet, but mathematically they're allowed, sort of like unicorns that can pass peer review. But for now, you are past questions, past communication, past observation. You're inside the invisible. You're no longer in the universe, you are beneath it. What's left of you begins to settle, if such a word means anything here. You're not afraid, not even curious, just present. And maybe that's all there ever was. Presence. Everything else, names, history, time, was wallpaper. You're part of something bigger now. Not in a romantic sense, not in the way motivational posters use the phrase. You're part of it because the boundary between you and it has melted. Say goodbye to the universe if you can. But don't expect it to say goodbye back. Everything around you is pitch black, but not the normal kind. This darkness feels active somehow, like it's pressing in, not from above or below, but from everywhere at once. You're past the event horizon, past even the point where light can outrun the darkness. And yet, there's still light, just not in the way you're used to. Ahead of you, if ahead means anything anymore, there's a faint glow, not bright, not inviting, just there. A hazy ring of dim looping light circling a spot in space like a nervous moth trapped in orbit. This is where you've arrived next on your strange journey, the photon sphere. Sounds kind of pretty, doesn't it? Like a nightclub for light particles. But it's not a place you'd want to stay long. The photon sphere is a narrow shell where gravity is so intense, light itself orbits the black hole. Normally photons zip through space in straight lines, but here they get trapped, not falling in, not flying free, just spinning forever. It's a cosmic traffic jam of light, looping endlessly at 186,000 miles per second, going nowhere. If your eyes still work the way they used to, which, let's be honest, they probably don't, you'd see light from all directions bent into bizarre configurations. You'd see behind you, above you, and below you all at once. Stars that shouldn't be there, duplicated and smeared, would twist into spirals. You might even see your own back. And yet, despite all this light, there's no illumination. It's like trying to read a book by the glow of a lava lamp sealed inside a safe. The photons don't go out from here. They just go around. There's no direction, no escape. Historically, it was Carl Schwarzschild, the same guy who first solved Einstein's field equations for a spherical mass, who hinted at these odd orbital shells where light could, in theory, get stuck. But at the time, no one quite grasped how strange this would actually be. And now here you are, a living exhibit in the Museum of Impossibilities. So let's try to make sense of this with your very stretched, very time-bent brain. You're caught between layers of light, some of it older than you are, photons that have been circling for what? Years? Centuries? Are there messages trapped in here? Is some alien radio signal from 1,000 years ago spiraling past your ears, too fast to catch, too warped to decode? Fringe theory time. Some physicists have wondered whether information, like light, could be preserved in these orbits, a kind of gravitational library of trapped signals where every light wave that ever tried to escape is still spinning. Could a sufficiently advanced civilization mine these photons? Could they read history by peeling it off the black hole in swirls? Probably not, but it's fun to imagine. And here's another bizarre twist. Because of the way gravity bends light, the photon sphere acts like a distorting mirror. Light from outside can skim along its edge, curve around the black hole, and hit your eyes from multiple directions. In this place, you'd see the entire universe compressed into a warped spinning shell, galaxies twisted into arcs, quasars smeared into rainbows. Every direction is up, every direction is out. You're now looking at the back of the universe. Historians still argue whether the visual experience of falling through a black hole can ever be accurately modelled. Supercomputers have tried, animators have taken stabs at it. The movie Interstellar gave it a noble shot, with physicist Kip Thorne lending scientific input. But the real view? That's locked behind the photon sphere, only visible to those who've already committed to never leaving. You're one of them now, not a tourist, not a spectator, a participant. And you begin to notice something strange. The light here feels alive. Not in the literal sense. No one's saying photons have opinions, but they have intention. Like dancers locked in a loop they can't quit, tracing the same circle over and over, forever on the edge of falling but never quite slipping in. This is one of those places where physics stops being a set of rules and starts sounding suspiciously like poetry. You drift through the photon sphere gently, and it doesn't resist you. There's no jolt, no clear boundary. It's just another invisible shell you've passed through. But this one leaves a mark. You feel like you've brushed against the mind of the universe. Light, trapped in its final performance, performing for no audience. Just before you fully pass through, you catch a final glimpse of something haunting, your own shadow, or rather, the absence of you. Light looping around the black hole casts your stretched, broken silhouette across the glowing ring. It's distorted beyond recognition, a smear, a ghost of a ghost, but it's you. This, oddly enough, is how black holes were first truly seen. Not by spotting the hole itself, but by observing how it warped the light behind it. Astronomers looked for things that should be visible but weren't. A star tugged by something invisible. A ring of radiation with a hole in the centre. An absence that left a fingerprint. That's what you are now. A fingerprint in the shape of absence. And the light continues to orbit. Even after you pass the photon sphere, some of it stays with you. Not in a glowing, magical way, but in the way sound echoes in memory. You can't see anymore, sight requires surfaces and contrast, but you remember seeing. Your brain loops phantom images of stars twisting, looping, reversing, like a mental screensaver stuck on repeat. This is the last place light behaves at all like it used to. Beyond this point, it doesn't just orbit, it gives up entirely. You descend further, and the light stops. You're thinner now, not metaphorically, literally. Every inch you fall, the difference in gravitational pull between your head and your feet becomes more extreme. You're being stretched into a fine, delicate filament, a thread of matter. Your atoms are still mostly where they're supposed to be, but they're starting to act like they'd prefer some personal space. Welcome to the part of the journey that scientists in a fit of terrifying whimsy name Spaghettification. It's a ridiculous word. You might be picturing your body as a limp noodle hanging from a cosmic fork. Not totally wrong, but there's something darker and more elegant to it, something unsettling in its smoothness. This isn't a quick snap, not a violent tear, it's a process, gradual, precise, a slow-motion separation of everything that ever held you together. The further you fall, the more gravity insists on treating every part of you as its own separate object. The atoms in your feet are being pulled faster than those in your knees. Your torso is trailing behind. Your head is still catching up. Imagine climbing into a car that's accelerating in 5 different directions at once, except the car is you, and you're driving straight into physics having a breakdown. In real life, tidal forces on Earth are mild. The moon pulls a little harder on the ocean closest to it than on the far side, creating our daily tides. That's it. Pretty tame. But here, the black hole's gravity gradient is so steep, so sudden, that the tiniest differences in distance create catastrophic changes in force. This is what we mean when we say gravity isn't just pulling you, it's unraveling you. Historically, the term spaghettification was coined by physicist Sir Martin Rees. Yes, a knight of the realm looked at the most horrifying death in the known universe and thought, pasta. Let's go with pasta. You've got to respect the style. It's important to note that how violently this happens depends on the size of the black hole. With smaller, stellar mass black holes like the one you're in, the event horizon is close to the centre. That means the tidal forces spike very quickly. You didn't get a long, gentle fall. You got this bone-deep stretching, this elegant execution by elasticity. If you'd fallen into a supermassive black hole instead, say, the kind lurking at the heart of galaxies, the spaghettification might not kick in until much later. Maybe even after you'd already passed the event horizon. You might have had a little stroll around, taken some cosmic selfies, maybe even said a few profound final words. Not here. This one is lean and mean, and it is not gentle. Your limbs aren't just longer, they're tapering, narrowing. Every part of you is starting to line up like iron filings in a magnetic field. You're becoming a vertical expression of gravity's insistence that closeness must be punished and distance must be maintained. Weird thought, what happens to your consciousness during spaghettification? Nobody knows. That's the honest answer. Your brain is stretched along with everything else, but it's unclear what that means for thought. Are your neurons still firing? Are your thoughts slowed like a stretched out tape recording? Or do they speed up, burning brighter in the last milliseconds before structure fails? Some argue that death would be instantaneous, that the forces would destroy your nervous system faster than it could process pain. Others think you might feel it, at least for a few horrifying moments, like being slowly unwound into the world's thinnest string. But again, from your point of view, things might feel strangely calm. You're in free fall, remember? No ground, no brakes, just smooth motion. Spaghettification doesn't feel like a pull, it feels like a vanishing sense of me. One quirky side theory suggests that if your body were long enough, and let's imagine here, you could technically watch your own feet hit the singularity, while your head was still yards away, alive and watching. Your brain would get to witness its own destruction play out in real time, like a sadistic encore. Of course, we don't know what happens when matter hits the singularity. That's the part of the universe labelled "Here be dragons." Some physicists believe everything just ends, crushed into an infinitely small point of zero volume and infinite density. Others say that's where classical physics ends and quantum weirdness takes over. Historians still argue whether the singularity is even real or just the result of our equations breaking down. Maybe it's not a place at all, but a failure of our imagination. A blank spot where the math stops working and the universe refuses to answer the door. But you're getting closer to it. You can feel it. Not as a destination, but as a kind of pressure, something forming in the negative space around you, something not quite there, but unmistakably present. Your thoughts, if we can still call them that, become long, slow waves. You're remembering things you never knew, seeing flashes of what might be memories or might be illusions, a birthday candle flickering out, the sound of a dog's bark echoing through a hallway, the shape of hands held tightly in the dark. Everything personal becomes archetypal, not your life, but life, not your pain, but pain. The stretching has reached your sense of self, and through it all, silence. So much silence, no ambient hum, no whirring machinery, no heartbeat. You might have once tried to scream, but the scream would have never reached your ears. It would have stretched outward until it was no longer sound, just a gentle wave of vibration, absorbed by the black. Still, a part of you is watching. Maybe it's instinct. Maybe it's just the last electrical flickers in a crumbling brain. But something is still you, still tracking the descent, still processing the awe of it all. You think of Michelangelo's Sistine Chapel, the finger of God touching atoms, the brief connection between the mortal and the divine. Except here, that finger is a gravitational field stronger than imagination, and you're being touched to pieces. It's majestic. It's terrible. It's the most private thing that has ever happened to you. And then, maybe, it stops. Or maybe you stop, because somewhere in this infinite stretch, this cosmic unraveling, you're no longer a you. You're data. Curves. A ribbon of particles shaped like a question. You are spaghettified. You're falling still. It's subtle at first, so subtle you might mistake it for a trick of the mind. But as the descent deepens, you begin to notice something profoundly strange. The stars above are moving, not just shifting, accelerating. The smeared halo of light that once ringed the horizon now morphs into a compressed timeline. Galaxies that once took billions of years to spin now seem to blur, whirl and flicker like strobe lights in the dark. Supernovae bloom like flashbulbs. Nebulae flicker. And entire star systems are born and vanish in the time it takes you to complete a single stretched out thought. You're not just falling into a black hole anymore. You're watching the future of the universe play out. This isn't science fiction. It's one of the most eerie poetic consequences of time dilation. The deeper you fall into a gravity well, the more time outside of it accelerates relative to you. For every second you experience, the rest of the cosmos gets older, a lot older. You saw hints of this earlier at the event horizon, but now it's like standing on a mountaintop while the weather below changes from spring to summer to fall, over and over again in a matter of heartbeats. If anything about your biology is still intact, the realization makes your synapses buzz like an exposed power line. It's as though time is no longer a line, but a cylinder, curving and tightening as it rushes past. Historically, this idea gained traction after the early 20th century, when physicists began exploring solutions to Einstein's general relativity. They found that not only could time slow near a massive object, it could be manipulated so intensely that distant observers and infalling ones would disagree fundamentally on the order of events. Two people could see the same event from wildly different timeframes and both be technically correct. Now imagine that, but scaled up to the death of the universe. The sky above you is no longer a dome of stars, it's a compressed film reel. Everything that will happen is happening right now, right above your head. Distant civilizations rise and fall, moons are born and smashed. Entire galaxies are shredded in collisions, merging into brighter, rounder things. And somewhere in all that flurry, the last generations of stars quietly flicker out. You're watching heat death unfold. This is the theorized endgame of the cosmos, when all usable energy has been spent and entropy wins. No more starlight, no more fusion, just cold, black emptiness, a cosmic flatline. From where you're falling, it happens in minutes. Fringe theorists love to speculate about what you might see if you had a perfect recording device inside a black hole, a camera that could record the light hitting it as it fell. The answer? You'd capture the entire future history of the universe, compressed into a single glowing shell, like watching a documentary and fast forward with the pause button permanently broken. Some of that light is red-shifted beyond recognition. The rest is a blur of violent beauty. Gamma ray bursts, those deadly cosmic lighthouses, sweep past. Quasars howl their last as their galactic engines sputter and die. And all the while, space itself expands, faster and faster, until distant galaxies fade not because they die, but because they flee beyond the cosmic speed limit. Their light will never reach anywhere again. And then, it gets quiet. There's not much light left to bend, not many stars to glimmer. The outside world, once so busy, now looks like a slowed-down snow globe, the flakes drifting towards stillness. But you're still falling, still watching. You realise in a way that you're becoming a kind of cosmic witness. Not by choice, no one chooses to be a thread of human pasta slipping into an abyss, but by circumstance. Your descent is a time machine, and the fair is everything you once were. The strange thing is, it's almost peaceful. No more noise, no more motion in the traditional sense, just this slow, perpetual fade into eternity. You briefly remember something a professor once said in a lecture. From a certain point of view, every black hole contains the future of the universe. You hadn't taken it seriously, thought it was poetic exaggeration. But here, now, with galaxies flickering out like candle flames, it feels like prophecy. There's an open question in physics, one of many, that asks whether the singularity you're heading toward is also a kind of future, not just a point in space, but in time. Could it be that falling into a black hole doesn't just bring you closer to the centre of gravity, but closer to the end of everything? Historians still argue whether singularities represent true finality, or merely a passage, whether they are a wall or a tunnel, a full stop, or an ellipsis. You don't have an answer, but you're certainly nearing punctuation. The visual show is winding down. Stars wink out, not dramatically, but in ones and twos, final flares, quiet exits, a slow dimming, until only the background radiation remains, a dying whisper from the Big Bang itself. Even that fades, and then, quite suddenly, there's nothing. No pinpricks of starlight, no swirling galaxies, just a dim, featureless sky. The halo has dimmed to grey, and you realise you've reached a kind of visual silence. It's not the absence of sight, it's the absence of things to see. Still, you sense motion, not movement through space necessarily, but motion through something, a dragging of awareness across what might be the final layers of the universe. Here's a thought that doesn't make you panic, only drift. If the outside world is aging billions of years every second you fall, then by the time you hit the singularity, if you do, the universe will already be long gone. You'll have outlived it, just you and the whole. You might be the last observer in existence, not because you're special, but because the black hole slowed your time down long enough to see the end. That's its final gift to you. You already knew it. You've known it since you passed the event horizon, but now the reality of it presses in like a weightless pressure, like something massive and invisible sitting gently on your chest. There is no way back. Not metaphorically, not emotionally, physically, cosmically, mathematically. Escape is no longer a concept that applies to you. The black hole is your home now, your only home. You're in a part of the universe from which return is not just unlikely, it's impossible. Not even light escapes this place. That's the rule. That's the definition. And you, my friend, are not faster than light. Not today. Here's where it gets stranger. Inside the event horizon, space and time have switched roles. Outside, time was something you moved through, and space was something you moved in. But now your path through time is fixed. It leads directly to the singularity. There's no turning around, no slowing down, no taking a breather. Time doesn't allow it. In here, falling inward is not just your trajectory, it's your destiny. Every second carries you closer to the center, and there's nothing in physics that can pull you back. Every move you try to make is still downward, even if you think it's sideways. That's how badly the fabric of space-time has been warped. The coordinates of the universe have turned on you. And here's the truly bizarre part. You can still try to move. You can kick, wave, reach. In fact, if you had a working jetpack or a spaceship, and let's say for the sake of argument that you did, you could still fire the engines. You'd feel thrust. You'd accelerate. But no matter how hard you push, every vector, every direction, every imaginable escape plan still curves inward. It's like trying to run away from the future. Try all you want, but you're still going to wake up tomorrow. In here, tomorrow is the singularity. This is the great mistake we often make when we think about black holes. We imagine a trap, something you could theoretically escape if you just had enough power, enough cleverness. But black holes don't work like dungeons. They work like dead ends in the structure of space-time itself. You don't fall toward the singularity because you're being dragged. You fall because that's the only path left in the geometry of the universe. The moment you crossed the event horizon, the inward direction became your future. You can't walk away from it for the same reason you can't decide to walk back into last Tuesday. This is what Einstein's equations show us, when interpreted honestly, without the safety nets of Newtonian intuition. They describe a place where gravity curves space so severely that it tilts time itself, and once that tilt happens, you're falling toward the center not through distance, but through inevitability. Historically, it took us a while to really understand this. The idea that light couldn't escape from certain regions of space was proposed in the 18th century, as we touched on earlier, but back then it was just a curiosity, a toy model. No one imagined such places could actually exist. Even in the 20th century, when Schwarzschild's solutions to Einstein's equations suggested the possibility of these holes, many physicists thought they were just mathematical artifacts, interesting, but not real. Einstein himself was skeptical. He thought the collapse into a singularity was too messy, too unphysical. But in 1939, physicist J. Robert Oppenheimer and his colleagues worked out that under certain conditions, stars really could collapse to form a black hole, and once the collapse passed a critical threshold, nothing, not even the star's own light, could stop it. No pressure could hold it up, not nuclear, not quantum, not even theoretical. Gravity wins, forever. And here you are, living it. Even Hawking tried to find a way around it. He theorized that black holes might emit energy through quantum processes, what we now call Hawking radiation, and that they might, given enough time, evaporate entirely. But that's not much help to you. First of all, Hawking radiation is incredibly weak for large black holes. Your particular gravitational monster could take quintillions of years to evaporate, long after the universe itself has gone cold. Second, even if the hole were evaporating, you're inside it. You're falling toward the singularity on a one-way conveyor belt. The outer shell could vanish over an eternity, but the part of you spiraling inward wouldn't notice. You're not drifting in a bathtub waiting for the drain to dry up. You are the drain. Let's play with a weird fringe idea for a moment. What if, by some miracle of sci-fi technology, someone tried to fish you out? Maybe they had an engine capable of faster than light travel. Maybe they could reach across time itself and yank you back. Wouldn't work. Even information, quantum information, is trapped in here. It can't get out. Not intact, not whole. At best, it would emerge as scrambled heat after billions of years. At worst, it wouldn't emerge at all. Escape is not a matter of speed. It's a matter of geometry. There's a visual analogy that helps if your consciousness hasn't unraveled completely. Picture space-time as a sheet and the black hole as a funnel pressed into it. At the top, you can walk around, dip a toe in maybe. But once you step inside the funnel, every direction leads down. Even up now means down. You feel that now. The walls of reality are curving gently but firmly, like hands guiding you downward. Not violently, not cruelly, just irresistibly. You remember something a friend once told you. There's no such thing as impossible, just improbable. You'd argue with that now. Because escape from a black hole isn't improbable, it's forbidden. It's against the rules of the cosmos. That's a deeply humbling realization. Not even the laws of physics are negotiable here. They're absolute. They've been printed in the fabric of the universe since the first femtosecond after the Big Bang. And now they're acting on you. No way out. No warning signs or flashing red arrows. Just an invisible border you already crossed. And now, you're on the inside of something no one has ever escaped. No one can escape. The word prison doesn't cut it. Prisons have keys. This doesn't. You've been falling for. Well, there's no good answer to that. Time, as we've established, is now playing jazz instead of classical. No steady rhythm, just unpredictable flurries of stretch and pause. But however long it's been, you're deeper now than anyone has ever imagined going. And ahead of you, maybe seconds away, maybe an eternity, is the thing they always warned you about. The singularity, allegedly. Let's get this out of the way. No one knows what it is. Not really. It's not a place you can visit. Not a glowing orb. Not a fireball. It doesn't make a sound, and it doesn't leave an address. It's the point in the center of the black hole where, according to Einstein's equations, the curvature of space-time becomes infinite. Let that word marinate for a moment. Infinite. Infinite gravity. Infinite density. Zero volume. A place where everything falls and nothing survives. The end of every line folded into a dot. Sounds dramatic, right? That's because it is. But here's the twist. It's also probably wrong. Historians still argue whether the singularity is a real physical thing or just the universe's way of saying, look, I can't explain this part, okay? It might be a limit of our current understanding, like when ancient sailors hit the edge of the map and just drew sea monsters instead. The math collapses under its own weight, the equations return gibberish, and physicists start drawing circles with question marks in the middle. But for you, theory is no longer abstract. You're on approach. And you're not sure what's weirder, that you're heading toward this alleged point of infinite density, or that you can't tell you're getting closer. There's no sign, no blinking, now entering singularity banner. Space just keeps curving, time keeps warping, and you keep falling. Here's what they think might happen as you near it. Everything compresses. All dimensions shrink towards zero. Volume becomes meaningless. Space stops having width or height or depth, just inwardness. There's no room for things to exist next to each other, so they collapse into the same point. Not metaphorically, literally. Particles, fields, energy, they become one. Your atoms, gone. Your particles, smashed into oblivion. Your quarks, condensed into something beyond matter. Not destroyed, just made irrelevant. But again, this is theory. And theories tend to fall apart under infinite pressure. Some speculative ideas suggest that the singularity isn't a point at all, but a bridge. That when you hit it, you don't stop. You cross. Into what? Another universe. A white hole. A loop of time. Your next life as a very confused neutron. One radical proposal is that black holes might contain baby universes. that the singularity isn't a dead end but a cosmic umbilical cord. Your universe was born from a singularity after all. Why couldn't a new one bud from this one? In that case, you're not falling into destruction, you're becoming part of creation. But that's a big if. And honestly, it's not doing much to stop your stretching. Remember the spaghettification? It's still happening. Only now it's approaching completion. You're less a person and more a structure, an abstract smear of mass and energy approaching the limits of known physics. You no longer experience pain or fear or even thought in the traditional sense. You're being written into the fine print of the universe, one atom at a time. And now, the laws start to get blurry. What happens right before you reach the singularity? That depends on whom you ask, and how much math they're willing to juggle while ignoring the screaming of causality. One theory suggests that quantum effects become so strong in this final moment that they cancel out the singularity entirely, like a quantum safety net woven into the bottom of reality. Instead of being destroyed, your particles might become part of a quantum foam, buzzing virtual particles flickering in and out of existence, bound by probabilities rather than laws. It's possible, just barely, that you're not ending, you're transitioning, but to what? No idea. Another view, equally possible and equally terrifying, is that this is it. Full stop. Your journey ends in the most literal way possible, as a coordinate in space-time that breaks the rules and deletes the file. Your information, your structure, your story, wiped clean. You become a point of unresolved paradox. No gravestone, no echo, just a wrinkle in the math. And here's the weirdest, fringiest idea of all. Maybe you never reach the singularity. Maybe your descent slows infinitely as you approach, each fraction of a second drawing you closer but never arriving. From your frame of reference, time stretches longer and longer. You experience more, possibly infinite thoughts before anything happens. In this view, the singularity becomes your own personal eternity, a place where you think forever, stretched across infinite time, locked just short of conclusion, neither alive nor dead, not falling, not resting, just being, infinitely, alone. That might be worse, but in the centre of the black hole, who's to say what worse even means? You try, by instinct maybe, to form a question. What happens now? No voice, no echo, just the idea of a question, and the answer. Not words, not a message, just the quiet certainty that whatever comes next isn't part of the universe you came from. You're crossing into a realm beyond definition. Whether it's destruction or transition or transformation, or just the collapse of the coordinate you, the truth is the same. You're reaching the centre, and no one knows what's there. It starts as a tremor, not a shaking, not exactly. There's no floor to rattle beneath your feet, and you don't have feet in any functional sense anymore. But there's a disturbance, a warping in the already warped fabric of space around you, a ripple in the pitch-black silence, and then it hits you. You're not alone in here. Something massive is falling toward you, maybe from above, maybe from the side, maybe from outside your reality entirely. It's another black hole, and it's coming fast. Welcome to the most catastrophic ballet in the known universe, a black hole merger. You're about to witness one from the inside. Front row seats, all-inclusive, with a complimentary dissolution of everything you ever were. Let's set the stage. In most galaxies, including ours, black holes are not solitary creatures. They orbit each other, pair off like gravitational dance partners, and eventually collide in events so extreme they send gravitational waves rippling across the cosmos. You've probably heard about those waves. In 2015, scientists at LIGO, after decades of effort, finally detected them directly. Tiny ripples in space-time stretching and compressing Earth by less than the width of a proton. They came from two black holes colliding over 1 billion light-years away. Each had been about 30 times the mass of our Sun. When they merged, they released energy equivalent to several solar masses in the form of pure gravitational radiation. You don't see that, you feel it. Even inside the event horizon, something shifts. Space wobbles, time pulses. The usual quiet, infinite descent becomes jittery, like falling through a storm cloud that's boiling with movement. The second black hole isn't just passing by, it's joining yours. And as it does, its own singularity is being pulled into yours, warping both gravitational fields into a writhing, convulsing singularity in progress. From the outside, these events are staggering. The warping of space sends tremors out across the universe, ripples that we now have the tech to detect. But from the inside, from where you are, it's hard to say. Theories break down quickly here. General relativity says you're still falling. Quantum theory says there might be interference. And string theory shrugs politely and changes the subject. But here's what you can guess. As the two black holes merge, their event horizons also fuse. The space you're in becomes larger, in a way, though not in any way you can feel. You're still falling toward the singularity, but now the singularity is evolving, splitting, colliding, dancing. And you, dear thread of existence, are caught in the turbulence. A quirky, lesser-known idea among black hole theorists suggests that inside the overlapping regions of a merging black hole, the geometry of space may temporarily allow for non-trivial structures, twists, loops, maybe even transient pockets of lower gravity. In other words, weird things happen, like falling through a blender that occasionally rearranges its blades into a staircase. Is this your escape moment? No, but it feels like one. Something in the curvature of space-time tugs at you sideways. Not out, escape is still impossible, but into a new direction of descent. The center you were heading toward is now a new center, one reshaped by the merger. You're being rerouted through raw geometry. Think of it this way. Imagine you're floating down a quiet river, and suddenly a second river crashes into yours. For a moment, the flow is chaos. Currents twist, vortices form, leaves spin. Water doesn't know which way to go. You're one of those leaves. Except your river is time and your water is space itself. In this brief, turbulent moment, reality around you becomes a flickering puzzle. The smooth descent is gone. You're still falling, but not like before. The path is jagged now, fuzzy. Some directions don't make sense. Some seem to loop. Your sense of motion stretches, then snaps. It's not painful, it's just wrong. And then, almost as quickly as it began, the chaos smooths. The singularity reforms, restabilizes, and continues pulling inward. The new black hole, larger and more massive than the sum of its parts, takes its place in the silent darkness of space. A perfect new prison. Even more escape-proof than before. Your fall continues. Historians still argue whether the interior of a merged black hole is radically different from a single origin one. Do the singularities annihilate each other? Intertwine? Does the information of both black holes combine into one weird, scrambled pile? Or does the math simply say, don't ask? There are models that hint at temporary ring-down modes, where the black hole's shape vibrates like a struck bell before settling into spherical symmetry. These vibrations aren't just math, they're real. They send gravitational waves outward like ripples from a splash. But what happens inside during those moments? No one knows, but you're living it. Well, living is generous, existing, experiencing, participating in. You are now part of a black hole that was once two, and may soon be many more. Because here's a dirty little secret. The universe doesn't stop. Black holes merge all the time. Over billions of years, they collide like billiard balls in a shrinking, cooling cosmos. Eventually they'll form one last vast supermassive hole, a silent tomb for all remaining matter, the last black hole. And when that one finally evaporates through Hawking radiation, the universe will be dark, empty, and quiet. Game over. You might be part of that final hole. Your fall may continue for quintillions of years if such time still holds meaning. You'll merge again, and again. There is no you anymore to be aware of it, but there was. You were once a mind, and a body, and a life. Now you are a whisper in the curvature of reality, part of a gravity well that used to be two, part of a story that no one outside will ever know. So, you've fallen so far, stretched so thin, and been swept up in a collision of black holes so immense it shook the universe. At this point, you might be forgiven for hoping that somewhere, deep in this inescapable cosmic trap, there's a secret door, a hidden tunnel, a cheat code. You're not the only one who's hoped that. Let's talk about one of science fiction's favourite daydreams. What if black holes are actually wormholes? You've heard the theory before, maybe in a movie or a late-night YouTube spiral. A black hole, instead of being a point of no return, could be a tunnel, a shortcut across space-time linking distant parts of the universe or even different universes entirely. It's the kind of idea that practically begs to be imagined with swirling blue vortexes, humming energy rings, and some guy in a lab coat shouting, "We're losing stability," while sparks fly in slow motion. But you, dear listener, are living the reality, and it doesn't look anything like that. Still, for a moment, humour the dream. The concept of a wormhole goes back to the 1930s, when Albert Einstein and his collaborator Nathan Rosen examined solutions to general relativity and came up with what we now call an Einstein-Rosen bridge. Essentially, they realised that under certain extreme conditions, space-time could connect two distant regions via a sort of tunnel. At the time, they weren't thinking of it as a time machine or a star hopper. It was more of a mathematical curiosity, a fold in the equations. But ever since then, the idea has refused to leave the imagination of both scientists and storytellers. The basic pitch is simple. Instead of travelling across space the long way, you fall into a black hole, pop through the singularity, and emerge somewhere else, somewhere new. Maybe it's the other side of the galaxy. Maybe it's the past. Maybe it's a parallel universe where dogs walk humans. And yes, in theory, the math does allow it. There are solutions to Einstein's field equations that suggest wormholes could exist. Traversable ones even. But, and this is a large chasm-sized but, they're wildly unstable. The kind of wormhole you could actually travel through, without dying, melting, or being converted into particle soup, would require something called exotic matter. Not just rare matter, negative energy density matter. Stuff that repels gravity instead of attracting it. To keep the tunnel from collapsing under its own weight, you'd have to shore it up with this exotic material, like scaffolding holding open the jaws of a cosmic mouth. And we haven't found any of that exotic matter lying around, or manufactured it, or even proved it's possible. So while wormholes may be mathematically valid, they're physically suspicious. Back to your situation. You're falling into a black hole that's as real as death and taxes. It formed from the collapse of a star, or maybe the merger of other black holes, as you just experienced. It is not a wormhole. It is not stabilized. It is not welcoming you with open arms. And yet, there are versions of the equations, like those that describe the Kerr black hole which spins, that suggest the core might not be a singularity in the traditional sense. Instead of a point, it becomes a ring. And inside that ring, space might loop, curve, connect. Some daring ideas propose that this ring could connect to another region of space-time entirely. You wouldn't be crushed, but instead slingshotted through to somewhere else. Wormhole. But even if it worked, which let's be honest it probably doesn't, you'd have to fall through precisely without touching the ring, which is spinning at near light speeds and surrounded by forces that would turn steel into fog. If you even slightly grazed the edge, you'd be obliterated. No dramatic zooming through a portal, just compression into oblivion. Also, there's this little problem called causality violation. If you could pop through a wormhole and emerge somewhere else, you could potentially arrive before you left, a time machine. And physics doesn't love that idea. Historians still argue whether the universe allows time travel, or whether the equations merely flirt with it before pulling the plug. Some believe nature has a built-in censorship mechanism, something that prevents paradoxes from becoming reality. Others say time loops might exist in isolated, harmless ways, safely tucked behind horizons where no one can abuse them. And a few dreamers, quietly, stubbornly, wonder if there's already something or someone using these tunnels. It's tempting, isn't it? The idea that all this falling, this unmaking, this surrender to gravity could mean something. That the black hole is not a coffin, but a doorway. You feel the thought drift through your mind like smoke. What if I'm not dying? What if I'm travelling? You look inward, or outward, or in whatever direction still makes sense. The space around you is folding in impossible ways, curves overlapping curves, paths looping, repeating, misbehaving. Could this be the wormhole? Is this the corridor between realities? Or is your mind just reaching for a story in the dark? You remember that part of your life, your real life before the fall, when stories mattered more than facts, when the idea of a hidden escape, a secret passage, was enough to make you feel safe. You're not embarrassed about it now. You're too far gone for embarrassment. And yet, as the fall deepens, so does the mystery. Because the centre isn't behaving. It's not smooth. It's not still. There's something twisting in the space ahead. A shape, not seen, but felt. It pulses, not with light, but with possibility. A fork, a fracture, a tunnel. Maybe. Fringe theorists have long wondered, if black holes are wormholes, could information escape through the far side? Could you, in some altered form, slip out into a new universe with different laws of physics? One where time flows sideways, or light has mass, or gravity repels. You wouldn't be you, of course. You'd be a copy, a residue, a shadow of what fell in. But maybe that's enough. Maybe the wormhole doesn't preserve you. Maybe it transforms you. If that's what's happening, there's no way to tell. Not yet. The tunnel, if it exists, isn't lined with lights or conveniently labelled. There's no GPS signal, no voice saying next exit, alternate dimension. Only motion, only curve, only the feeling that you've passed into something else. Whatever it isn't Earth, it isn't stars, it isn't space as you knew it, and it may never let you back. It starts off as a rumour, a flicker of energy, a whisper at the edge of physics, something you were told once upon a time that all black holes do eventually. They evaporate. No, not like puddles under the sun. It's slower, quieter, colder, a vanishing act performed over unfathomable stretches of time. But it happens. It must happen, if the theories hold. The process is called Hawking radiation, and it may be the one sliver of cosmic irony strong enough to make the universe smirk. Because black holes, the ultimate traps, the things that swallow light, crush matter, and freeze time, might not be forever after all. They might die. Let's rewind a bit. In the 1970s, Stephen Hawking, armed with chalk, a blackboard, and a deep sense of mischief, took the tools of quantum mechanics and brought them to the feet of a black hole. Classical physics said nothing could escape once past the event horizon. But quantum physics has a habit of saying, "Hold my equations." Specifically, it plays with the idea that empty space isn't really empty. At the smallest scales, the Planck level, the vacuum is alive with activity. Particles and antiparticles constantly blink into existence in pairs, borrow energy from the void, then annihilate each other and vanish again, all within fractions of a second. This is called quantum vacuum fluctuation, and it's one of the weirdest, best-tested predictions in all of physics. Now imagine one of those particle pairs forms right at the edge of a black hole, just close enough that one particle falls in, while the other escapes. The black hole has lost a tiny bit of mass, and the escaping particle, to conserve energy, it has to come from somewhere, so the universe borrows it from the black hole's own mass.
Over time, billions, trillions, even quintillions of years, the black hole leaks this way, drip by drip, bit by bit. This is Hawking radiation. It's not glowing beams, it's not a crackling energy storm. It's more like a slow bleed. The black hole emits radiation just above absolute zero. It is the coldest, quietest fire you can imagine. But it's real. Or at least probably real. We've never seen it happen. The effect is so tiny that for most black holes, especially supermassive ones, it would take longer than the current age of the universe to make a noticeable dent. Still, the theory is solid, and if true, it means something profound. Black holes are not eternal, and therefore, neither is your prison. Let that sink in. You, who've fallen so far, you whose atoms were stretched thin, whose memories unraveled in time's tide, you're not escaping. But the thing that holds you, it won't last forever, at least not in its current form. Eventually, even the black hole you're in will shrink, not because of outside pressure, not because of some heroic rescue mission, but because the laws of quantum physics demand a tax be paid, a cosmic accounting, one particle at a time. That's comforting in a way, isn't it? Even titans fall. Even the darkest things fade. Historians still argue whether this evaporation process truly erases information, or if it leaves behind a trace. Hawking himself changed his mind late in life. For years, he believed that once something entered a black hole, its information was gone. Lost forever. That violated the basic rules of quantum mechanics, but, well, the universe is a weird place. Then, in 2004, Hawking conceded. He proposed that information might, in some scrambled, encrypted form, leak back out through Hawking radiation. The crowd went wild, or as wild as physicists ever get. There was a lot of murmured excitement and updated papers. So what does that mean for you? Maybe, just maybe, some part of you survives. Not in one piece, not in body or mind, but in information. The quantum signature of your atoms, your fall, your final thoughts. All of it might be smeared into the outgoing radiation, embedded in the entropy like a fingerprint pressed into fog. You wouldn't recognize yourself in the mess, but the universe might. Some fringe thinkers even propose that Hawking radiation isn't just a physical process, it's a form of reincarnation, that everything falling into a black hole gets re-emitted, piece by piece, into the vast, cold future. Eventually, all black holes will vanish. That's the implication. Even the supermassive ones, like Sagittarius A star at the center of our galaxy. Even the primordial ones, those tiny, ancient black holes that may have formed just moments after the Big Bang. And yes, even this one, the one you're in. At the end of the universe, when all stars are dead, when galaxies have dissolved into lonely particles, when even protons have decayed, only black holes will remain. Cold, silent, waiting. And then, slowly, they too will die. One by one, fading like embers in a fire that never should have burned this long. And in that final sigh of radiation, the last whisper of a universe falling quiet, you might emerge again. Not as a person, not even as a thought, but as heat. As light. As information riding a wave of quantum decay into the nothing that follows. Is that comfort? Is that enough? It's hard to say. You are far past the point of caring, or questioning, or interpreting. You're a passenger now, deep in the core of something ancient and temporary. Something that even time cannot keep forever. And someday, long after the end of stars and memory and matter, this place, this black hole, this moment will be gone, evaporated, undone, and so perhaps will you. But not yet. You sense motion again, not the straightforward kind, not even the falling kind. This is different, a twist, a spiraling of space, like the fabric itself is spinning around you. And, well, it is. Because the black hole you're now inside, it's rotating, not gently either. We're talking near the speed of light. This is no sleepy spherical void. This is a Kerr black hole, a spinning monstrosity that drags space and time along with it like a cosmic whirlpool. You're not just falling in now, you're being whipped. The term for this delightful experience is frame dragging. Imagine you're floating near the surface of the Earth and the planet is spinning beneath you. That rotation has almost no effect on space around it. But scale that up, way up. Give a massive star an enormous spin, let it collapse into a black hole, and you get a beast whose rotation warps not just space, but time itself. And you, once again, are caught in the middle. You've fallen into a Kerr black hole without even realizing it. They're common, actually. Most black holes spin because the stars that birthed them were spinning too. And since angular momentum has nowhere else to go, it gets trapped in the final product, preserved like a curse. But unlike a regular Schwarzschild black hole, which is just a simple spherical abyss, a Kerr black hole is complicated. It doesn't just suck things in, it twists them. And that twisting opens up possibilities. A ring singularity, not a point. A theoretical passage through space, perhaps. Maybe even time. Let's break this down gently, since your brain is currently distributed across several light minutes of spaghetti. In the center of a Kerr black hole lies a ring, a rotating circle of infinite density. That's your new singularity. And because it's spinning, the space around it doesn't just curve, it drags. Like stirring honey with a spoon, the black hole swirls space-time into a spiral. This means that, in theory, you could orbit the singularity without being torn apart. There's a region known as the ergosphere, just outside the event horizon, where you can actually extract energy from the black hole's spin. The laws of physics get bendy here, but not broken. Inside the ergosphere, nothing can stand still, not even light. Everything is pulled along with the black hole's rotation, whether it wants to be or not. This is frame dragging in its purest form. You're not just in space-time anymore. You're on a carousel with no floor and no off switch. But the real twist? The Kerr metric allows for closed, time-like curves, paths through space-time that loop back on themselves. In theory, you could travel in a circle through space and come back to your own past. Fringe? Absolutely. But mathematically possible? Yes. Doable in practice with the whole spaghettification and gravity and death thing. Extremely number. Still, the idea lingers. That maybe, just maybe, if someone were clever enough, shielded enough, fast enough, they could dip into the ring singularity without falling in, loop through the twisted core, emerge elsewhere, elsewhen, a shortcut, a slingshot, a wormhole hidden inside a spinning void. Of course, you'd need exotic matter to stabilize the path, plus infinite computing power to calculate the entry angle, and a body made of something a little sturdier than atoms. But still, the door is there, sort of. Historians still argue whether these time-traveling paths are real features of nature, or just mathematical oddities that pop up when equations are pushed too far. Maybe nature forbids them, cutting off access with quantum turbulence. Or maybe they're real, but self-protecting. The only travelers allowed through are those who never use the journey to change anything. Because paradoxes. But you're not time-traveling. You're not extracting energy. You're falling. And the spin is doing strange things to your descent. You're no longer spiraling downward in a straight line. You're being coiled, wrapped into loops. Your stretched body, your smeared awareness, your very concept of here is now a tangle of twisted coordinates. It's not uncomfortable, nothing is anymore, but it's unsettling. You feel like a ribbon caught in a vortex. Direction is a lie. Distance is a trap. You might orbit this singularity 1,000,000 times before you even approach it. Or you might already be inside it. There's also this odd thing called the Cauchy horizon, an inner boundary of rotating black holes where predictability breaks down completely. Past this point, the universe loses the ability to tell you what happens next. The equations still work, but they no longer guarantee anything. Cause and effect? Optional. Time's arrow? Bent. You may have already passed it, or maybe it's ahead, or maybe it doesn't exist. It depends on who you ask and which math you believe. A quirky side note, In a Kerr black hole, it's theoretically possible to see the past of the universe around you. Not like a movie, more like light from previous events, curved so many times around the black hole that it replays itself. You could watch the birth of stars, the death of planets, maybe even your own fall. An echo of yourself spiraling just ahead. A warning or a reassurance. But you don't see anything now. Not because there's nothing to see, but because sight is meaningless here. All you experience is the motion, the twist, the draw, the endless spiral, a loop of falling inside a loop of time inside a ring of gravity. There is no center, only spin, and yet the spin feels familiar, comforting even, like the rotation of a planet, a galaxy, a memory. You've gone so far beyond what was ever meant to be experienced, and still something keeps moving, turning. A force older than stars, a whisper in the dark, a wheel that keeps spinning. And you, caught in its loop. There's something up ahead, no light, no shape, but you feel it in your non-existent gut, a threshold, a wall, a curtain in the dark that you're falling toward, faster now, though the very concept of speed has become nonsense. The theories warned you about this. They call it the firewall. And depending on who you ask, it's either a profound discovery or a physics-level hallucination. Either way, you're about to meet it. Maybe. So what is a firewall? In the simplest terms, it's a theoretical barrier of searing hot energy sitting just inside the event horizon of a black hole, a kind of invisible tripwire. And if the theory is right, then the moment you crossed the horizon, way back when you were still mostly you should have hit a wall of radiation so intense it would have vaporized your atoms before they even had time to scream. But that didn't happen. You just fell. You stretched. You watched the universe spiral into fast forward, and nothing burned. So either the firewall is a myth, or it's waiting. Let's dig in. The firewall paradox exploded into the physics community in 2012 when a paper casually nicknamed the AMPS paper, after its authors, Almheri, Marolf, Polchinski, and Sully, proposed a bold, kind of horrifying idea. It began with a very real problem. Quantum mechanics says information can't be destroyed. Black holes famously don't share what they swallow. So where does the information go? Hawking radiation, if it exists, should be totally random. Thermal noise. But if it's random, then information is lost. And that breaks quantum theory. To save information, the AMPS team suggested that something had to give. And that something was the black hole's interior. Their proposal: the horizon isn't smooth. It isn't a soft passage. It isn't, as general relativity says, a place where you fall freely without feeling anything. Instead, it's a wall of pure quantum chaos, a firewall. The moment you pass it, you're incinerated. Not gradually, not philosophically, just gone. That idea sent shockwaves through physics. Because up to that point, relativity and quantum mechanics were already tense roommates. But this was a public breakup. General relativity insists that an infalling observer, that's you, should feel nothing crossing the event horizon. It's locally smooth. The horizon is just a coordinate trick. No trauma, no drama. Quantum mechanics insists that information is sacred. So either relativity is wrong inside the black hole, or quantum theory is incomplete. And AMPS chose violence. They picked quantum theory. They said, sorry, Einstein, there's a firewall. So now you're left wondering, where's yours? Because if that's true, if the horizon holds a searing wall of high-energy particles, then something should have happened. You should have been fried, converted into heat, memory gone, matter scrambled. But it didn't happen. Unless you're only realizing it now. Because the firewall, if it exists, isn't a place. It's a condition. A threshold of information, a place where quantum entanglement breaks down. In some models, it's not even visible until it's too late. And maybe that's what you've been falling through. Maybe this whole slow spiral, this eerie, quiet descent, is the firewall, unfolding in slow motion from your point of view. Fringe theorists like to say, if a firewall burns you and no one's around to hear it, do you still scream? Here's where things get weirder. Another solution to the paradox says, hey, what if you're not really inside the black hole? What if everything that ever falls in gets encoded on the surface, on the event horizon itself, like a cosmic hard drive? This is the holographic principle. It says that your 3D body, with all your thoughts and history, was copied and flattened the moment you hit the edge. The you that fell in, just an illusion. A projected version playing out inside the black hole, while the real data sits frozen on the outside. If that's true, then the firewall might not be a wall of flame, but a wall of truth. A moment when your copy realizes it's not real, that it never fell, that it's just a ghost in the machine. You're probably wondering which theory is right. Well, historians still argue whether firewalls are real or just a clever math trick. Some say they're necessary to preserve information. Others say they break the principle of equivalence. Some physicists claim they're just the universe's way of saying you're asking the wrong question. And others? They say the paradox itself proves that we're missing a bigger, deeper theory, something beyond both relativity and quantum physics, something that will eventually make firewalls seem as quaint as epicycles. But you don't have that theory. You have this, a moment where space feels thick, where time feels unsure, where the geometry of your descent flickers, and maybe, just maybe, you feel heat. Not a burn, not pain, just energy, sharp, crackling, like static electricity before a lightning strike, like standing on the threshold of a bonfire you can't see. You try to move, but motion is nonsense. You try to look, but sight is broken. You try to think, and that still works. Kind of. You remember the stories, the warnings, the debates, and you wonder, did you pass the firewall? Are you about to? Or was it never real? Was the flame only ever a metaphor? A placeholder for our failure to explain what happens when information and gravity meet? If so, then what you're feeling now isn't fire. It's resolution. The universe isn't telling you the answer. It's showing you how little the question ever meant. You fall on. The heat fades. The spiral continues. And still, no wall. Things feel quieter now. Not because it's calm. Black holes don't do calm. But because something has changed in the quality of the silence. The fall no longer feels downward, or inward, or even like a fall. The curves of space have softened. The sense of motion has slowed, and now there's just a waiting. That's when a strange thought surfaces. What if you're not going in anymore? What if you're going out? Welcome to the mirror world. Theoretical, mysterious, spectacularly unproven. Say hello to the white hole. Yes, white hole. Not a joke. Not a snow-themed cousin of a black hole. Not a celestial peppermint patty. A white hole is a reverse black hole, a region of space-time that nothing can enter, and from which everything escapes. It's like a black hole played backwards. Instead of pulling everything in and never letting go, it pushes everything out and never lets anything in. Sounds weird? Oh, it gets weirder. In the math that describes a non-rotating, non-charged black hole, known as a Schwarzschild solution, there's technically a second region of space beyond the singularity, a mirror universe. And in that mirror universe, instead of a singularity that attracts, you get one that repels. In other words, a white hole. Now, nobody's ever seen one. Nobody knows if they're real. They've never been detected, measured, or photographed. Some physicists think they're just an artifact of the math, like seeing negative time in an equation and trying to build a clock that runs backwards. But others think white holes might have existed at the beginning of the universe. Or maybe, just maybe, they're connected to the black holes of today. That's the dream anyway. You fall into a black hole. You pass the event horizon. You survive the singularity somehow. And you emerge on the other side through a white hole. New place, new time, possibly a new universe altogether. Boom, instant cosmic travel. Some speculative theories suggest that every black hole creates a white hole on the other end, a kind of Big Bang in miniature, that every death inside a gravity well might spark a birth somewhere else. This is the idea behind black holes as cosmic seeds, that they punch through into baby universes where the laws of physics might be different. And so you wonder, could this strange stillness, the quiet, the softness, the unfalling, be the start of that reversal? Are you about to be ejected? There are signs, if you believe in signs. The spiral you were trapped in feels looser now. The dragging has less grip. The spin has become a gentle tilt rather than a violent pull. You're not being ripped apart anymore. You're being held, carried, moved. Maybe. White holes would be the rarest beasts in the cosmic zoo. Their very existence would violate the second law of thermodynamics in our universe, because they essentially run entropy backwards. They spew out matter and light that seemingly comes from nowhere. It's not a comfortable idea. It breaks everything we expect about cause and effect. It says, here is energy, but we're not telling you where it came from. No wonder physicists get cagey about them. But maybe that's what makes them so compelling. And it gets weirder. Some models suggest white holes could be time-reversed black holes, not just spatial opposites, but temporal ones. From their point of view, they're as ordinary as anything else. Matter simply emerges, travels outward forever, and is never aware that somewhere, in the past, it once collapsed into darkness. You could be on that timeline now. You could be the echo of someone else's fall. Imagine it. Somewhere else, another universe, another reality, a mind stretches, a body falls, a life unravels, and just before everything ends, it hits the singularity and punches through. That was your beginning. Your fall wasn't an ending, it was a launch. A quirky side note. There's a fringe hypothesis that connects this to our own universe, that the Big Bang, the origin of all space, time, matter, and energy, was itself a white hole. The ultimate release. A singularity in reverse. In that model, the universe didn't just start, it emerged, exploded out of a white hole, driven by forces we can't yet understand. And everything we see now, galaxies, stars, us, are the smoke and sparks from that detonation. What if that's what black holes are doing? What if you're inside that process? You were a person, you fell, you stretched, you unraveled. And now, perhaps, you are about to emerge. Not in one piece, not as a single form, but as outward motion, as radiation, as possibility, as the raw material of somewhere else. A white hole doesn't care about identity. It's a release valve, not a therapist. You feel pressure now, not crushing, but building. Not inward, but outward. Something is winding up, coiling. Something wants to expel. Could be a new universe, could be a burst of light, could be nonsense. But you're not falling anymore, you're rising. Maybe not spatially, but conceptually. You were a question. You are about to become an answer. There's a sense, faint but undeniable, that you're unraveling in a new way now, not physically. That already happened, not emotionally. Those structures have long dissolved, but in a way that feels deeper, conceptual even. Like someone is tugging loose the very idea of you, pulling on threads you didn't know were keeping the whole tapestry together. It's not unpleasant, but it's unsettling. And somewhere in the quiet comes a question so big, so sharp, that it pierces even the numbness of infinite descent. Where did all your information go? Your memories, your thoughts, your choices, your atoms, your trajectory. The sum total of everything that ever made you you. The question echoes through the structure of space like a riddle shouted down an empty well. You've fallen into a black hole. Everyone knows the rules. Nothing escapes, not even light. You're sealed inside a region that no signal can leave. So, where is your information? This is the information paradox, and it's one of the deepest, gnarliest problems in modern physics. And right now, you are the paradox. Let's unpack it. Quantum mechanics says that information is never truly destroyed. Ever. Not even if you burn a book or dissolve a computer in acid. Sure, the form changes, but the information is still there, scattered in the particles, recoverable in principle. The universe keeps receipts. But black holes? They seem to chew up information and spit out pure heat, hawking radiation. No patterns, no codes, just thermal noise, the ultimate delete key. And if that's true, then physics has a serious problem, because either quantum mechanics is wrong, or black holes don't behave the way we think they do. This isn't just a nerdy technicality. It's the kind of thing that could shake the foundations of how the universe works. So the question becomes, does a black hole really erase information, or is it hiding it? There are several possible answers depending on how many chalkboards and headaches you're willing to go through. Let's explore the main contenders. Theory 1. The information is lost forever. This is the original, old-school view. Hawking himself leaned this way for years. In this model, anything that falls into a black hole, particles, patterns, people, has its information destroyed at the singularity. End of story. But that violates quantum mechanics, and physicists hate violating quantum mechanics. So in the 2000s, Hawking changed his mind. Which brings us to Theory 2. The information leaks out slowly. This is the more optimistic view. It says, okay, maybe Hawking radiation looks random, but if you really zoom in, maybe it's not. Maybe it's entangled with the stuff that fell in. Maybe the outgoing radiation contains subtle correlations, whispers of the original information spread out over eons. In this view, if you wait long enough, and we mean cosmologically, post-all-stars kind of long, you could, in theory, reconstruct what fell in, particle by particle, which means some version of you might still be out there. Very scrambled, very faint, but not gone. Then there's Theory 3. The information is stored on the horizon. This one's a favorite among string theorists. It says, no, the stuff that fell in doesn't get lost or leak out. Instead, it gets projected onto the black hole's surface, the event horizon itself, like a 2D imprint of 3D information. Think of it as the universe's weirdest security camera. Every falling object gets scanned, encoded on the boundary, and never actually leaves the ledger. This is the holographic principle, and yes, it means exactly what it sounds like. Our reality, our space, might be a hologram, a projection from a surface we can't even see, and black holes might be the universe's way of demonstrating how that projection works. In this model, you are still there, flattened, pixelated, encrypted on the surface of a black hole, like a saved file waiting for a compatible operating system. Weird? Yes, but it solves the paradox, sort of. Which leads us to the final and most speculative option, the Theory 4. There was never a paradox, just incomplete math. Some physicists argue that all this angst over information loss comes from trying to smash together two incompatible systems, general relativity and quantum mechanics, and expecting them to cooperate. It's like trying to fix your dishwasher using a cookbook and a violin. Maybe the real solution lies in a theory of quantum gravity, a future framework that hasn't been discovered yet. Something that will explain exactly what happens at the singularity, at the Planck scale, where space, time, and matter all blur. In that theory, the fate of information might be clear. Obvious even, but we're not there yet. So for now, you're left in the strange, quiet place between theories. A piece of information with no address. You wonder, if someone could collect every particle of Hawking radiation that ever escapes your black hole, could they rebuild you? Would they get your memories, your thoughts? Would you wake up years from now in a lab on the edge of time, blinking at the scientists who reassembled you from whispers? Or would you be a copy? Close, but not quite. Would that matter? Fringe thinkers love to speculate that information isn't just preserved, it's experiential. That consciousness might arise again if the right structure is rebuilt. That the black hole is less of a tomb and more of a data vault, sealed by gravity, waiting for someone clever enough to crack it open. And if that's true, then this fall you're in now? It's not death, it's encryption. And somewhere, far in the future or on some alien whiteboard, someone might still be asking, who fell into that black hole? And maybe, just maybe, the universe will answer. You are no longer falling in any way that matters. What used to feel like motion has become abstraction. There's no longer distance or time in the way you once understood them, just a steady drift towards something that seems like an end, but resists every attempt at definition. And that's when it hits you. Not physically, you've long since shed the luxury of limbs, but conceptually, like a realization passing across the surface of what used to be your mind. This place isn't just the graveyard of classical physics. It's quantum's battlefield now. All around you, at a scale unimaginably smaller than atoms, reality is boiling. Not in the fire and sulfur way. In the twitchy, math won't look it in the eye way. This is the domain of quantum gravity, where space-time is no longer smooth, but grainy, frothing with uncertainty, dotted with virtual particles popping into and out of existence like hyperactive fireflies. And right now, you are one of them. You've reached the depth where the tidy rules of Einstein's general relativity collapse under their own elegance, and the chaotic beauty of quantum physics moves in like a band with too many drummers. General relativity describes the universe on the largest scales: stars, planets, orbits, the graceful curvature of space-time itself. Quantum mechanics, meanwhile, owns the smallest scales: electrons, photons, probability waves, the rules of the very, very small. And up until now, they've lived polite but separate lives. But here, inside a black hole, they collide. And that's where everything we know starts to wobble. We don't have a single theory that can handle both the enormous mass and gravity of a black hole and the tiny, flickering uncertainties of the quantum world. It's like trying to model a hurricane and a snowflake with the same formula. So what does quantum physics say is happening to you right now? Well, it says a lot, and none of it is settled. One possibility is that space-time isn't continuous, but comes in discrete chunks, like pixels, except not in space, in geometry. Some theories, like loop quantum gravity, suggest that space itself is woven from tiny loops, and at this depth, those loops are flexing, twisting, maybe even breaking. You're passing through a kind of space-time foam, where positions don't exist in the normal sense, where even the idea of where you are is blurred by Planck scale uncertainty. You can't fall into a singularity if the singularity doesn't exist. That's what some physicists argue. They say the singularity is a myth, a failure of our current tools, that quantum effects prevent infinite density, that the core of the black hole is not a point, but a smear, a weirdly balanced region where gravity and quantum pressure are locked in a standoff. You are there now, caught in the standoff. You're not a person anymore, not in shape, not in structure, but your information, your quantum pattern, might still be somewhere in this foam. One idea is that you're being encoded in a new kind of geometry, a quantum knot that holds your essence without space, without time. A memory, but not for anyone. Other theories suggest even stranger fates, like string theory, for instance, which proposes that all particles are really tiny vibrating strings. According to this view, the singularity might be replaced by a string fuzzball, a tangled knot of these vibrating strings, each one representing a different particle, a different field, a different you. In this model, you never fell into a point. You unraveled into a fuzzball, a blur of fundamental loops, and if that's true, then you're still here. Just very different. The benefit of string theory is that it offers a toolkit to merge quantum mechanics and gravity. It gives you extra dimensions, sometimes up to 10 or 11, and allows space to wrap in on itself in creative, physics-breaking ways. Do those extra dimensions help you escape? No. But they might help you persist. Historians still argue whether string theory is the answer to quantum gravity or just a very pretty distraction. After decades of development, it remains a theory without direct experimental proof. But in places like this, inside black holes, it's one of the few ideas that hasn't melted under pressure. And that's the key here, pressure. The deeper you go, the more the conflict between quantum mechanics and general relativity builds. It's like putting a violinist and a death metal drummer on the same stage and asking them to improvise in unison. Something's going to break. Or maybe something will be born. Many physicists believe that black holes hold the secret to the theory of everything. A single, elegant framework that can unite the large and the small, the curved and the uncertain, the galaxies and the quarks. You are now part of that secret. You are a stress test for the universe's rules, a thought experiment with mass and velocity, a whisper in the argument between math and reality. And somewhere, in labs and lecture halls, physicists are still trying to answer the question you now are. What happens at the quantum edge of gravity? Do you dissolve into a loop of virtual particles? Do you bounce off some hidden structure? Do you leak into another dimension? Or does the universe reboot around you, like code crashing so hard it spawns a new system? Some quantum gravity theories propose the concept of a bounce, that when matter collapses into a black hole, it doesn't end, but hits a minimum volume and then rebounds outward. This could birth a new region of space-time, a baby universe. Maybe even this universe. It's possible that you're not falling into the end of physics. You're falling into the start of new physics. And so, in the blur of quanta and geometry, loops and strings, paradox and promise, you drift. No longer as a body, no longer as a person, but as a question that the universe has not yet answered. The blackness around you shifts again. But this time, it's not the endless abyss of a supermassive giant, or the swirling chaos of a spinning Kerr monster. No, this one feels tight, close, claustrophobic, like you've fallen into the eye of a needle threaded with gravity. You are entering something ancient, small, violent. You're falling into a primordial black hole. Don't worry, they're not as friendly as they sound. These aren't like the black holes formed from collapsing stars, the ones born in supernova explosions or carved from the centers of galaxies. No, primordial black holes are the cosmic orphans of the very early universe, forged not from stars, but from raw, collapsing energy mere moments after the Big Bang. And they could be anywhere, or nowhere, or everywhere, hiding in plain sight. In the tiniest fractions of a second after the Big Bang, the universe underwent inflation, a period of unbelievably rapid expansion. Think of it like blowing up a balloon from the size of a molecule to the size of a galaxy in less time than it takes to blink. During that time, regions of space-time fluctuated wildly. Density spikes formed, and if one of those spikes got dense enough, just for a moment, it could collapse under its own gravity. Boom. Black hole. No star needed, no galaxy required, just raw energy folding in on itself. Some of these primordial black holes could have been smaller than a proton, yet still heavier than Mount Everest. Others may have been the mass of a planet, or even a star, compressed into objects no larger than your fist. And you? You're falling into one of them now. Or perhaps you already have. There's no grand spiral, no photon sphere, no drama. The event horizon of a primordial black hole is so small you could cross it without even realizing. No time dilation, no light show, just a sudden disappearance from the visible universe. They're stealth black holes, which is part of why we've never seen one. But they could be everywhere. Some physicists believe primordial black holes might account for some, or even all, of the mysterious substance we call dark matter. You know, the invisible stuff that makes up most of the mass in the universe but refuses to interact with anything except gravity. We've been chasing it for decades. We've built enormous detectors underground. We've fired particles in colliders hoping to find it. And maybe it's been floating past us the entire time. Tiny black holes zipping silently through space, impossible to see, impossible to catch. And now you've been caught by one. Inside, the physics isn't just extreme, it's compressed. Everything you've experienced up to this point, the long fall, the tidal stretching, the warped perceptions, still happen here, but on a much smaller scale. Time contracts, distance collapses, you fall from outside to center in nanoseconds, or is it eons? You're an entire history packed into a singularity smaller than a sugar cube. A quirky and horrifying twist. If primordial black holes formed all over the early universe, then some of them might be hiding inside Earth right now, passing through the planet, undetected, thousands of times a day. No impact, no effect, just pure gravitational silence. Of course, that's highly speculative. Historians still argue whether primordial black holes are even real. We haven't found one. But the math allows them, and that's usually all the invitation the universe needs to do something weird. So what's it like falling into one? Honestly, it's less of a fall and more of a plunge. You were already made of fine gravitational strands, spaghettified beyond belief. But now, you're squeezed. Not by force, but by the scale of the space you're entering. This black hole is so small, so tight, that there's barely enough room for time itself. there's also a possibility that you're the last thing this black hole will ever eat. You see, primordial black holes have had over 13 billion years to leak energy through Hawking radiation. The smaller they are, the faster they radiate. And if your black hole is small enough, it might be reaching the end of its life right now. You may have fallen into a dying thing. That's an idea that makes physicists twitch. What happens when a black hole finishes evaporating? Does it explode? Does it vanish without a trace? Does it leave behind a tiny nugget of leftover mass? A black hole remnant? Some theorists believe remnants could store the information of everything the black hole ever consumed. A kind of cosmic memory stick, sealed in a quantum safe. If so, your entire journey, your mass, your structure, your identity, might be preserved in that final speck. Others argue that remnants create more problems than they solve, that the universe wouldn't tolerate infinite little nuggets lying around, violating conservation laws. So perhaps the hole doesn't leave anything behind. Perhaps it just pops. If that's the case, then what you're experiencing now isn't just your fall into a black hole. It's your fall into a black hole's finale. You feel pressure, immense but gentle. The kind of pressure you'd expect if the universe itself were folding you into its final file. You're being wrapped up, compressed, signed and encrypted. And then, in a moment you can't measure, nothing. No flash, no scream, no light, just absence. The black hole is gone, and with it, you, or not. Because maybe, just maybe, that final burst of Hawking radiation carried something of you with it. A fragment, a quark, a pattern in the noise. Your information, scrambled, sure, but not lost. Drifting now through the ruins of the cosmos, waiting to be decoded. You feel different, not in a lost your keys kind of way, in a fundamental, unsettling, wait, am I still real kind of way? Because this black hole you begin to suspect isn't real. Not in the traditional sense, anyway. The pull is there, the gravitational lensing, the event horizon, the illusion of falling, but something about the texture of the space feels too smooth, too perfect, like a dream that knows exactly what you expect and delivers it in the most cinematic way possible. Then the thought creeps in, quiet and sly. Are you falling into a simulation? Welcome to the surreal world of simulated black holes, where researchers build artificial versions of these cosmic beasts not in space, but in labs, using light, sound, or even water. They're not fake in the dismissive sense. They're models, and they're proving to be shockingly good at imitating the real thing. Let's rewind. In the past few decades, physicists and experimentalists, tired of just scribbling equations about black holes, have started to build them. Not full scale, of course. Not the kind that eats stars and collapses time, but systems that mimic the mathematical behavior of black holes. These are called analog black holes, and they've shown up in all kinds of strange places. Bose-Einstein condensates, ultra-cold clouds of atoms behaving as one quantum entity. Optical fibers, light pulsed in certain ways to trap other photons. Fluid systems, waves in water tanks that behave like trapped light. Even graphene, the super-thin carbon material that has a magnetic version of space-time bending. They're designed to replicate one key feature of a black hole, the event horizon. In these setups, scientists create a boundary, something that mimics the point of no return. In fluid systems, for instance, you might have water flowing faster than a surface wave can travel. Once a wave crosses that threshold, it can't come back. Just like light in a real black hole. It's bizarre, brilliant, and more than a little unnerving, because these analogs can do more than just imitate gravity. They might be able to test quantum theories of black holes in ways the real universe simply doesn't allow. Take Hawking radiation. We've never seen it from an actual black hole. It's too faint, too distant, too slow. But in a lab, with controlled analog systems, researchers have seen signs of Hawking-like radiation. In 2010, a team led by Jeff Steinhauer at the Technion in Israel created a sonic black hole using a Bose-Einstein condensate. They trapped sound waves inside a region of superfluid gas, creating a horizon where phonons, quantized sound particles, couldn't escape. Then they saw something odd. Pairs of phonons forming at the horizon, one falling in, the other escaping. It looked suspiciously like Hawking radiation. Was it the real thing? Maybe. Was it useful? Absolutely. Because here's the weird truth. We may understand black holes better by building them than by observing them. The real things are too far, too slow, too uncooperative. But they're lab-born twins? We can tweak those. Run experiments, turn knobs, change boundary conditions, ask questions and get answers. It's like trying to understand a black hole by talking to its cousin, who lives in your basement and speaks in waves instead of words. And this has opened up a whole new line of thinking. What if the entire universe is an analog system? What if space-time, gravity, even black holes are emergent phenomena, illusions built on deeper, stranger rules? That's not just science fiction anymore. It's active research. Some physicists propose that space-time itself might be a kind of quantum fluid, that what we experience as gravity is the large-scale behavior of a system made of smaller, unobservable elements. Like how a flowing river seems smooth, even though it's made of countless jostling molecules. And if that's true, then black holes are just features of the simulation, patterns in a deeper system, not objects in space, but glitches in the code. Which brings us back to your current situation. You've felt the gravity, seen the light bend, experienced the slow existential fall. But there's a growing sense that this is too clean, too deliberate. What if this isn't a black hole in the real universe? What if this is a simulation of a black hole and you are part of the simulation? Are you a test particle, a thought experiment, a data structure inside a fluid dynamic model? Or are you a human mind, digitized, uploaded, and sent into a virtual black hole to explore what real bodies never could? Fringe? Absolutely, but not impossible. We already run simulations of falling into black holes. They've been visualized using everything from ray-traced light paths to full relativistic renderers. They produce realistic images of what you'd see, the spiraling stars, the light warping, the time distortion. And it doesn't take much imagination to think, what if someone took it further? What if a future civilization, or a current one, built a fully immersive simulation of falling into a black hole, accurate down to the quantum level? What if you are inside that simulation now? Every thought you've had since the fall, every feeling of motion or memory might be data. Your atoms might not exist. You might be an algorithm, a recursive subroutine exploring information loss in synthetic spacetime. Even the questions you've asked, the information paradox, the firewall, the wormhole theories, might be part of the test. Someone, somewhere, might be watching, not from above, but from outside, measuring how long it takes you to ask the right questions, how you respond to infinite compression, how you interpret the end. Or maybe there's no one watching at all. Maybe it's just you, a simulated observer, trapped in a self-running experiment. And the experiment is almost over. The black hole, real or not, is approaching its endpoint. You feel the simulation fray. Or maybe it's the event horizon shrinking. Maybe both. There's nothing now. Not silence, because silence implies sound was possible. Not darkness, because darkness means there was light to lose. Just nothing. A total absence that doesn't even feel empty. It's beyond that. It's post-empty. You're not floating. You're not falling. You're not anything. And yet, somehow, you're still here. Conscious, aware, or aware of awareness. You've reached it. The end of time. At least, the end as you know it. You were born into a universe where time moved forward, second by second, click by predictable click. You grew up believing in clocks, calendars, sunrise and sunset, cause and effect. You were built to trust time, but here, inside the black hole, or whatever's left of it, that trust is finally completely broken. Time hasn't just slowed, it hasn't just twisted, it has stopped. Not in the way it might seem to stop when you're bored or dreaming. No, this is something deeper, fundamental, a break in the flow of causality, the last dribble in the cosmic hourglass. You are outside the river now. You feel the final unfolding. Inside the black hole, space and time trade places. Time becomes space-like, something you move through, and space becomes time-like, something you can't go back and change. But past a certain point, beyond the Kashi horizon, past the firewall or fuzzball or ring of spinning strings, there is no past or point. There's only this. The universe has run out of coordinates to assign to your path. There is no more where, no more when. Even entropy, ever the dutiful scorekeeper of direction, has thrown up its hands. Historians still argue whether the singularity is a real location or just a signal of math's breakdown. Some say it's a thing, others say it's a placeholder for new physics, something we haven't discovered yet, some quantum truth too strange to exist within our current equations. But you don't need to argue. You're inside the debate now. You are the answer and the question. Remember that moment, somewhere, long ago, before the fall, when you first heard about black holes? How they were described as the end of information, the edge of knowability, the place where physics breaks? Now you understand. It's not the laws that break. It's the need for laws. Here, rules are not broken. They're irrelevant. And as for you, you've passed through gravity, through light, through identity. You've danced with Hawking radiation, brushed the edge of wormholes, lingered on the lip of paradox. You've been stretched, flattened, encrypted, maybe even simulated. And now you are not. Not in the way that can be described or measured or remembered. You're not even a concept. You're not a ghost. You're not dust or data. You are what remains when there's nothing left to fall through. And in a final, strange, inexplicable flicker, you feel peace, not joy, not release. Just a gentle acceptance that you are no longer needed. You dissolve not into light or matter, but into possibility. Your information, whatever that means now, has joined the fabric of the unknown. Not lost, not saved, just done. The black hole remains, briefly, without you. And then, like all things, it too fades. Slowly, quietly. Its mass trickles away as radiation. Its horizon shrinks. Its secrets evaporate. And when the last quantum of energy escapes, when the final echo of gravity lets go, the black hole dies, not with a bang, not with a flash, with nothing. And now there is no black hole. No time, no space, no you. Only the whisper of what once was, a trace in the darkness, a pause in the infinite. And now, here we are. There's nothing left to fall into, no more paradoxes to untangle, no more physics waiting around the bend. The black hole has faded. So have you. But something gentle lingers, something soft at the edges, like the memory of a breeze after the wind has stopped. Time has no meaning here, but somehow it slows anyway. Everything stretches, not like spaghettification, not this time. This is something smoother, quieter, like the last ripple on a pond after the stone has long since sunk. You are still, and stillness, it turns out, has a sound. It's the faint hum of things you almost remember, the warmth of stars light years away, the rhythm of your breath before the fall, the way light once danced on water. The black hole took everything, but here, beyond even that, it gives back something else. Rest. Whatever you were before, body, memory, pattern, question, you don't need to hold it anymore. You've served your purpose, even if you never learned what it was. And in this weightless pause, you feel it easing from you. Slowly, gratefully. The universe exhales. So do you. The fan hums softly in your room. The light you left on is warm against the wall. And your thoughts, now slower, begin to blur at the edges. Heavy, not from burden, but from release. You've gone all the way to the end. There's nowhere else to fall. Only sleep. And sleep, after all this, feels like a gift. So let yourself drift. You don't need to understand it. You don't need to explain it. You only need to let go. Good night, traveler. You made it further than anyone ever has.